Hello, we will continue our discussion on cloud computing, different aspects of cloud computing. So, what we are discussing during this phase of these lectures is more looking at the different other aspects of cloud computing which make this computing more efficient, what are the different supportive technologies around it, and how the overall cloud computing may be made more practical, right. So, one of the aspects of this cloud is its energy consumption. We have seen in case of when we discussed about resource management that resource is in the cloud, though theoretically there is infinite volume of resources, but the resources to be managed appropriately so that the service can be provided to the maximum to maximize its benefit, right. So, it is a type of situation what we looked at, that where it is a win-win situation for both the consumer and the provider, and how this resource can be managed. One of the aspect of resource management what we have discussed is to reduce the energy consumption, right. What is seen that this overall measure the dark side, so called dark side of this cloud computing is huge volume of energy consumption or huge amount of energy consumption. If you have experience in any type of going through, or if you have read any type of data centers, or if you go through this internet different resources, you will find that typically if you look at a data center, the cost of the computing equipments or computing infrastructure is somewhere match with the other environmental infrastructure, like the space, environment, AC, power, and so forth. So, it is something like X is spent on this, is more or less X is also spent on that site, right. Rather, in some cases it is more costly because of the cost of the particular space and power and type of things. Secondly, the amount of energy spent in maintaining this type of infrastructure is enormous, right. And what is being seen that unless this overall consumption things consumption pattern can be reduced, or the volume of consumption can be reduced in some way or other, it may not be feasible to scale up after a extent, right, after a particular limit. So, though someone can have infinite or someone can have money to spend, but there may not be, the supply is not available to the things. So, in other and another aspect what we see, that it is becoming sometimes it is a more hazardous or more negative effect on our environment, especially the carbon footprint. More you consume, more energy being produced, more is the carbon footprint. So, going to other unconventional energy sources may be other things, etc. Nevertheless, the overall this computing world need to look for some sort of a more quote unquote green computing. So, what we will discuss today briefly is that different aspect of green cloud computing, though it has direct connection or direct relations with our resource management, but we will try to look at the different aspects of this green cloud computing. And if whenever we are setting up any infrastructure, so this should we should keep in the mind not only the cost of the infrastructure, but also this consumption of energy, how to reduce that consumption of energy, and so forth type of things, right. So, that is what we discussed today, is the green cloud. If we quickly revisit our definition. So, what it says, that it is a cloud computing is a model for enabling convenient on demand network access to a shared pool of configurable resources like network, server, storage, applications and services. Like this is the first line. There are different characteristics, like we say that it can scale up or infinite scaling. It has the ability of metered service, broad network access, and different characteristics are there, omnipresent or ubiquitous access to these computing facilities and type of things. Nevertheless, these definitions, what if we look at other in a little deeper way, there is a lot of energy hungry resources are there, right. Like if you even look at networks, servers, storage and applications and services which run of the things, they all take lot of energy. If we can efficiently use those, there may be a chance that we can reduce the overall energy consumption. Otherwise, the energy consumption may be considerably high. Like say if I say that if I have my running VMs are say number of servers I am having 4, my number of running VMs are again 4. So, every server can accommodate say running VM is 8 and every server can accommodate 4 VMs. So, it may so happen that every server is distributed 2 VM per server. It may look good that there is a load is distributed, but if you look at the energy point of view, the energy consumption may be pretty high. Instead, I could have packed them into 2 server of 4 each and so on and so forth, and other 2 server I can put on a off mode or a sleep mode or a passive mode, and this could have saved energy in a bigger way. So, these are the aspects which we need to try to look at, and there is definitely it is not like that simple how we are trying to pose the problem, how we are discussing, but there may be a lot of calculation of projection and type of things. There are issues of SLAs, QoS and type of things, but nevertheless taking all those into consideration, there is lot of opportunities may be there to go green, right. So, if we visit this means see the other slide. So, at the down we have this infrastructure, right, where cloud physical resources, storage, virtualized clusters, servers, networks like Amazon EC2, GoGrid and different other solutions are there. At the middle we have cloud programming environment or platform and cloud hosting platforms which uses this infrastructure, and there are Google App Engine, MapReduce, Microsoft Azure, Aneka and type of things, and at the top we have this SaaS or software as a service, scientific computing, etc. Now, this in turn every layer, upper layer in turn uses the downwards layer, and a more efficient is this computing at every more efficient is the implementation of each layer may help us in reducing the overall energy consumption, right. So, it is not only that efficiency out here, though when we look about energy we mostly look at the IaaS type of things, but it is also that at a higher layers also contribute type also contribute towards this proper energy management, right. Like if I have an algorithm which takes unnecessary loops and takes more CPU time, that may be energy inefficient than more efficient algorithm which where we can reduce the complexity and type of things, right. So, it at much higher level I can do something which in turn reduces my energy consumption or CPU uses time or network uses time, and that in turn reduces the overall energy consumption at the of the cloud infrastructure, right. So, looking at this, if we try to look at green cloud. So, green computing is a environmentally responsible and eco-friendly use of computers and their resources, right. So, its first cut is that it should be environmentally responsible, means minimum carbon footprint and so on, and eco-friendly use of computers. In broader terms, it is also defined as a study of designing, manufacturing or engineering, using and disposing of computer devices in such a way to reduces the environmental impact, right. So, if we look at that how the designing, manufacturing, engineering and those things go on. Green cloud computing is envisaged as a to achieve not only efficient processing and utilization of computing infrastructure, but also minimize the energy consumption, right. So, it is not only not only it will be efficient in processing and computing and maintaining QoS and SLA, but also it gives minimize the energy consumption. So, when we look about talk about green cloud computing, we look both sides of the thing. Cloud advantages are well known. If we again look quickly, reduce spending on technology infrastructure. So, what we feel that instead of infrastructure I shift to the cloud infrastructure, globalize your workforce in a chip, so that it is omnipresent, streamline processes, reduce capital cost, improve accessibility, minimize licensing of new software, improve flexibility. So, there is a host number of advantages are there, which may in turns try to reduce the computing at different in a different environment and going like in terms of setting up your infrastructure at your local things and going to the things. So, in a sense it may appear that we are in a sense we are reducing energy consumption, but at the other end the consumption things increases. So, what we are trying to look at is not that what we save out here, we are more at look at the how to make those service provider ends, how things can be made more efficient. So, challenge especially in terms of energy consumption and carbon footprint, like if you see the Gartner report on 2007, IT industry consumes 2% of the world, contributes to the 2% of the world's total carbon dioxide emission. So, it is a pretty high, right, though it talks about IT industries as a whole, but this major player or the cloud service provider are major contributor of the things, right. Their cooling, their overall energy consumption is pretty high, like big data centers installation, people say that it is like it's a mini city, like consuming power so highly. Like, so there is another report which say 1.5% of the US power consumption used by data center, which has more than doubled since 2007. It is also around 2000 since 2000 and cost $4.5 billion, right. It is also a report which is around 2007. So, in down the line 7 years it has more than doubled, right. So, as it is a ever increasing phenomena that this shifting towards cloud or cloud industry is growing at a much pretty higher rate. So, this figure of energy consumption is likely to increase much more than getting reduced. So, it is more demand for cloud, more energy consumption and so forth, right. So, there is a need of green cloud computing, definitely there is a need of green cloud computing. So, importance of energy, increased computing demand, data centers are rapidly growing, consume 10 to 100 times more energy per square foot than typical office building, right. This is a one rough cut thing. Energy cost dynamics, energy accounts for 10% of the data center operational cost, right. What other things what we say OPEX, and can rise to 50% of the next few years. What they say that it is such a high rise going on. Again, some report said that the cooling system cost around $2 to $5 million per year. This is also somewhere 2013 or so, that report which came up. So, again a rough cut, if we see the energy consumption. So, the equipment takes around 40%, power distribution takes around 15%, cooling system around 45%. So, if you say if you look at the computing equipment is taking 40% over the total energy, rest 60% is taking by this infrastructure. It means cloud environment infrastructure itself, right. To set up this cloud, that we need to set the environment, that is AC, power distribution, appropriately power distribution, UPS supply, etc., that taking over the 60% of the energy, and the computing is around 40%. So, computing stays less. Now, if you look at the DC architecture, so this is also evolving, right. It is also changing over time, and more complex equipment are coming. Of course, more energy efficient equipment are also coming. So, two-tier DC architecture, access. So, initially it was access and core layers. So, you have the centralized core layer, which is a highly mesh. They are interconnected with a very concentrated mesh network, and there are access layers. From here the things are these are the different access layers, right. This is the, if you look at the DC architecture type of things, computing architecture. So, full mesh core network, load balancing using ICMP protocol, right. So, this is typically there. So, there are different type of switches, layer 3 switches, layer 2 and layer 3 rack switches, and computing servers. So, computing servers at the end mile or at the edge, and this layer 3 switches which routes traffic are at the core of the network. So, this is the typical architecture which was typically there in means old or past DCs, though there are still some of the things are still existing. So, rather like all other large network, this DC architecture present, which see as a 3-tier DC architecture, that is most widely used nowadays, access, aggregation and core layer. So, there is a access layer, there is a aggregation layer. So, it is not only this layer 3 switches at the core, but also layer 3 switches at the aggregation layers, and then we have that this access layer. So, it is a hierarchical structure made to proper management and appropriate distribution with minimization of or better load balancing and type of things, and so and so forth, right. So, this is more for it is more amicable for to scale up. It scales up much better than our previous things, like scales over 10,000 servers and so forth for a particular DC. So, it is a this sort of architectures are there. So, along with that, it has high speed architecture, 3-tier high speed architecture, increased core network bandwidth, two-way ECMP load balancing. So, 100 gigabit Ethernet standard connection over the thing. So, it is a much higher thing. So, what we have think previous thing was a standard connectivity with 1 to 10 gigabit connectivity, whereas here we have a jump of 100 gigabit connectivity. So, these links are very high speed links, and then we have much lower links at the down the line, right. So, this so it is better aggregations, better scaling up, and better management of that whole infrastructure is there. So, it is more better responsive type of architecture. So, this present days architecture, whenever we deploy all those things, these are again we need to look at the energy consumption of the things. It is not only facilitates better computing or better accessibility of the computing things, but also it consume at times much more energy, right. So, we need to have a trade off, that whether there is a requirement of such things, or that facilitating or providing services and increasing energy performance versus energy trade off should be there. Though we do not compromise on, do not want to compromise on performance, but making it efficient or energy efficient is another goal. So, this is a typical energy model of DC server energy model, what you see that even in the idle server consumes about 66% of the peak load of the CPU frequency. Even in this idle state, it takes a considerable amount of energy. So, that it is always a running energy. So, ideally if a particular service provider has no load something, it has to maintain the things. It is like if we consider that is in a if you in a particular shop, say ice cream parlor or so, even there is no customer or not that particular customer, it has to maintain as a particular level of cooling and type of things, right. So, it is some sort of a energy level is there. There are there are different model of energy models. In this case, that is we have a fixed power model where the memory modules, disk, etc. Another CPU based on that frequency and number of CPU up, etc. We can have another other models. Similarly, if you look at the switches energy model, so there are different category of things. One is that what we see that the chassis where if we have say a bunch of blade servers, so it goes into a chassis, right. So, typically say chassis can contain the 16 blades or of half height size. So, that chassis itself consume energy. So, if you look at that the around 36% of the a typical figure, just to show you a rough cut figure that how things how the energy is important. A chassis consume around 36%, the line cards around 53%, and this port transceiver where the data being transmitted or received is 11%, right. So, this model that P chassis plus number of line cards into P line cards and that number of aggregation of the number of ports, and along with that the summation of the things with that number of ports is that summation of the energy consumption will be the overall switching energy consumption. And that is also if we see that it can be considerable based on that if it is properly loaded and type of things, like I can have traffic appropriately distributed, I can have a better figure out here. So, this all those things has a definite impact on the environment, right, or environment. This environment is not what we are talking about the cloud environment, but it is environment as a whole, that overall environment, like as we have talked about carbon footprinting, there may be effect of heating, there may be other different sort of polluting effect, right. So, data centers are not only expensive to maintain, but also unfriendly to the environment. It can be unfriendly. Carbon emission due to data center worldwide is now more than both Argentina and Netherlands emission. So, this is one figure, it shows that the carbon emissions due to data centers worldwide is more than 2 countries overall emission. High energy cost and huge carbon footprints are incurred due to massive amount of electricity needed to power and cool numerous servers hosted in these data centers, right. So, this is another major challenge of looking at it. So, it is a huge energy consumption. So, we need to balance between this performance versus energy efficiency. As the energy cost increasing while availability decreases, there is a need to shift focus from optimizing data centers resource management for pure performance alone to optimizing energy efficiency while maintaining high service level performance. So, as like when we talk about resource management, we may be looking primarily on the performance alone, right. So, we need to look at that performance vis-a-vis this energy management. So, how overall this can be achieved, performance versus energy efficiency can be achieved is there. Like reducing power cost and maximizing revenue may be the thing, like power cost and carbon emissions are ever increasing. So, we need to look at in a more practical way. So, if you look at in the modeling terms, so in our this model this energy component should come into play, right, that how that need to be managed, how need to be controlled should come into play. There are several initiatives needed from the cloud service providers end, like cloud service provider need to adopt measures to ensure that their profit margin is not dramatically reduced due to high energy cost, right. Amazon's estimate one figure shows that the energy related cost to the data center amount to 42% of the total budget and include both direct power consumption and cooling infrastructure amortized over 15-year period. Google, Microsoft, Yahoo are building large data center in barren desert land surrounded by Columbia river to exploit the cheap hydroelectric power, etc. So, that is a tendency of make the data center more near to the power generation unit. So, that your transmission of power, transmission loss, etc. are reduced to a drastically. So, if we this is a typical green cloud architecture, if we look at, so there are at the bottom end these physical machines, there are several virtual machines, and this green cloud allocator, what we say now the green cloud brokering system. So, which brokers in favor of the consumers. So, this is a grid negotiator, service analyzer, consumer profiler, pricing, energy monitor, service scheduling, VM manager, accounting. These components were otherwise also there in the architecture. What we see more is looking at that energy consumption related parameter or metrics come into play, right. So, a broker which look at QoS and energy based provisioning of the different cloud service provider. Based on this, they provision on these different cloud service provider. So, it is more energy aware provisioning of services. So, similar that green, if you look at the green broker, so it has a typical cloud broker leads cloud services schedule application, that is the major duty of the things. So, when you look at the green broker, so analyze user requirement, calculate cost and carbon footprint of the services, carbon aware scheduling. So, the now the scheduling is carbon aware scheduling, right. Brokering services such as scheduling monitoring, carbon dioxide analyzing services, cloud request services. So, it does a carbon aware scheduling. Similarly, we have a green middleware where what we say that green IaaS. So, so what if you remember the initial figure. So, we said storage, virtualized service, etc., energy, temperature sensor, demand predictor is added. Here also we have at the PaaS level that green profiler, power capping, green compiler, similarly green resource allocation system at the PaaS level. In the SaaS level, power capping, green software services, and so on and so forth. So, these are the different way we try to address these issues. There is some effort of looking at that power uses effectiveness measure to find out that what is PUE and how to measure that how effectiveness is this power uses. So, there are different theories behind it. So, this is a rough cut measure that how whether we can measure this power uses effectiveness of a typical infrastructure or a typical cloud service provider. So, to summarize, clouds are essentially data centers hosting application services offered on subscription basis. However, they consume high energy to maintain their operations. So, high operational cost plus additionally environmental impact, which we try to ignore. So, that is one of the major aspects presented. So, what we look at the carbon aware green computing framework to look at. So, there are several open issues, lot of research to be carried out to maximize energy efficiency in cloud centers, developing regions to benefits the most that where should be situation and so on and so forth. So, what we see overall that overall this sort of computing aspects has a major concern not only from the service provider or consumer point of view, it is a concern worldwide from the environment point of view, that the huge amount of energy being consumed, which has a carbon footprint and a better, and there is a need for better energy management to for so that this sort of cloud computing environment in with lot of benefits are able to exploited by the consumer. Okay. So, we need to head for some sort of a green cloud computing environment. Thank you.